Hey guys, and welcome to Inverse of Functions, the fifth video in a video series on polynomials and functions. Okay, so just as a quick reminder so you know where I'm coming from here, when we talk about inverses, we always use the inverse operation, just regular inverse. We always use the inverse operation when we solve equations. So over here, right here, this is -6 or -6. To get rid of it, because we want to solve for our x here, to get rid of this -6, we simply add 6. Okay, and when we add 6 to both sides, that's 0, and this is 24. This is 2 times here, this is 2 times x. So in order to get rid of that 2, we use the inverse operation, which is division. Okay? And then we wind up getting x equals 12. So that's the idea of inverses. So when we talk about inverses, like the additive inverse means, well, two things are additive inverses. If, let's say, 5, I want to add these two things together and I get the identity. That's what an inverse is, or inverses. The identity for addition is 0, and it's an identity because if you add anything plus 0, it stays the same. It keeps its identity. So what could we add to 5 here? Oh, where'd it go? Oh, I'm on the wrong thing, sorry. What could we add to 5 here to get 0? Well, it's the inverse of it. It's -5. So that means 5 and -5 are additive inverses of each other. Multiplicative inverses uses the idea of division. So additive inverse means two things multiplied together equal the multiplicative identity, which is 1. So the multiplicative identity is 1 because anything times 1, it keeps its identity. That's what, so whenever you multiply times 1, it doesn't do anything. Okay, that's what that means. So the multiplicative inverse is basically division, or you flip it. Okay? So these two guys multiply together equal 1. That's multiplicative inverse. Kind of unwinds it. It gets you back to the identity. Okay? The two put together get you back to the identity. But the inverse of functions is a bit different, but still related in that sense. The inverse of functions is you take a function, so let's say this is a function. Okay, functions are bunches of points, okay, put together to form curves or shapes. Okay, and then a function, as you recall from algebra, has other ideas, but the basic idea behind inverse of a function is it reflects the function through the line y equals x. Okay, and when we say reflected through the line y equals x, maybe you remember it from last year from geometry, when you did reflections and things like that. When you reflect anything through the line y equals x and x equals y. So they get switched. No sign changes, just switch. So you simply switch x and y. That's it. That's what the inverse is. It has lots of special properties and things like that. And as we get deeper into functions, you're going to see the greatness of them. Okay? The notation for the inverse of a function. So the notation for a function is like f of x. Okay, that's how you say that. This is a function notation. Okay, the inverse notation, the notation for an inverse is f of f inverse of x. That's how you say that. So it says f inverse of x. That's actually how you say that. You don't say it to the -1 power, but it does look like a -1 power. It is not. It's actually the notation for the inverse. So if you see this, they're asking you to find the inverse. Okay, that's what the inverse of functions are, and that's what we're going to be doing today. Okay, just as a quick reminder, when you're solving an equation, what is the inverse of these things? Like, what do you do when you add and you want to get rid of addition? The inverse of it is basically subtracting. When you subtract, the inverse is add. When you multiply, you divide. Divide, multiply. Squaring is square rooting, and this is... So, in other words, if you had x squared equals 9, to get rid of the squared, we just do a quick square root, and it's x equals plus or minus 3. So it could be a positive 3 or a negative 3. That's how we do it. So x could equal 3 or x could equal negative 3. I know in geometry you usually just eliminated the negative. We don't. So we have to have both answers. And the inverse of square rooting is squaring. And you've all done this before. It's like the square root of x equals 5. In order to get rid of that radical and get the x by itself, we simply square both sides. And when we square both sides, you get x. These kind of cancel themselves out, and it's x equals 25. And when you square 5, it's just 25. Okay? To find the inverse of things, the basic steps are written at the bottom. Oh, you didn't see that. Are written at the bottom of this. One more time, and I'm smacking myself. Okay, right here. Okay, so just keep those in mind. I probably should have written them at the top, but I didn't. First thing you got to do is change your f of x to y, because we reflected through the line y equals x, and in each of these problems that you see up above, like this problem, there's no y. You don't see a y at all. Okay, so f of x is your y. Then switch the x and the y, just switch what they are. Where there's an x, put a y, and vice versa. Solve for y and put the notation in. So the hardest part is the solving, but the rest of it, you should be able to do these with relative ease. So your first step is make f of x y. And it's really just because it's easier to solve with the y than f of x, because it looks weird. Second step, switch the x and the y. Literally just take these two and switch them. No numbers, nothing else changes, just gets switched. And the last step is to solve for y. So I have to get this y by itself. So we have to solve equations. Okay, so to get y by itself, I have to add my 3. I changed colors. And then divide by 2. Now, we can't add x and 3, so we just leave it. And then divide the whole thing by 2. And that's your inverse. So this one's, the inverse is, that's f, the inverse of f of x is x plus 3 over 2. Now, you have to recognize also that you could divide this 2 into both of those pieces, so you could get x over 2 plus 3 over 2, or also 1/2 x plus 3 over 2. These are all the same answer. Okay, you're in kind of higher math now. You have to be able to recognize that these are all really the same thing. Okay, let's just do a couple more of these, just so you can see the basic idea. So, y, change f of x to y. Switch your x and your y. So everyone should be able to do those, everyone should be able to do those 2 steps regardless. If they don't have f of x, if they have y here instead, well then you can skip the first step and just switch the x and the y. Now this is division here, divide by 4. So there's 2 things you can do when you divide. The inverse of it is multiplying, so I can multiply both sides by 4. Or you could also do the something similar and just cross multiply. Both work. Okay, it's still multiplying. So this cancels out and you're left with y minus 3 equals 4 times x. And then you add 3. 4x plus 3 is equal to your y, so just replace it with the inverse. Done. Okay. 2 more. Now we'll just show you a couple with squaring and square rooting so you can understand. First step, y equals x squared minus 3. X equals y squared minus 3. Notice exponent stayed here. Okay, it's just the x and the y switch. Then you solve. Add 3. X plus 3 equals y squared. To get rid of the squaring here, we got a square root. And the moment we put that square root on here, you put it on yourself. It wasn't given to you. You put it on to solve. That goes away, and you have to put plus or minus radical x plus 3. That's your y. Okay, so it's the inverse of x, f, you know what I'm saying, is plus or minus the square root of x plus 3. Okay? Do some practice in class, and hopefully that won't be too confusing. But you're basically just solving equations here. So a quick y equals, notice this one has the square root on it. We don't put the plus or minus. You only do that when you put the plus or minus on. Okay? Now, at this point, I can't do anything until this radical goes away. So I have to square both sides to get rid of it. So when I square it, this radical goes away, but I still need to square this side. Okay? And then I solve. Plus 7, x squared plus 7 equals 4y, and then divide by 4. There you go. So it's the inverse is x squared plus 7 over 4. But remember, all the million of different ways you can write this. Just divide the 4 into both, and know that there is a 1 here, so this could also be written as 1/4 x squared plus 7 over 4. You have to get a little comfortable with fractions. You're going to see them a lot. All right? Thank you. Bye.